Note 4.9, parallel and perpendicular lines. If at any time I go too fast, you can pause this, rewind it, make sure that you write down everything that's on here. Today we're answering the question, how do you know that two lines are parallel to each other? You've done this in other maths, right? Two lines going off. How do you know that they will never ever touch each other? Most of the time you've just been told that they'll never touch each other, but now let's see what's actually going to happen. We're going to start by graphing a equation 2x plus 3 on our Cartesian plane. Just to review how to graph, and then I'm going to graph a parallel line, then you're going to see how did I get that line that was parallel to it. So 2x plus 3, remember the 3 is starting value, the 2 is the slope. So we have this starting point here, 3. We go up on the y-axis to 3. We put our first point. And then the slope, the m, tells us what to do. Slope's 2 over 1. So from our starting position here, if we go up 2 squares and over 1, I put a dot. That's the next point on my line. And then I go up 2 and over 1. Same thing, up 2 over 1. If I'm savvy, I can go backwards and follow the pattern, but you don't have to. Once you think you've got enough points, that's when you make your line. Hopefully make it straighter than me. There it is. Y equals 2x plus 1. Now, if I wanted a parallel line to this, I want a line going in the same direction, same angle, but I just don't want it to ever touch. So I can draw a line at the same angle, and this line will never ever touch it. And I know that because I've made it that way. Now the thing is, what do you know about these two parallel lines? How do you know for sure that these two lines are never ever going to touch each other? That's why, by the way, they were made. So two parallel lines, they will always have the same errors. They won't have the same error. They will always have this. Jeebus. They're going to have the same slope. All right, if I go back to that original one, right, this blue line here, right, it's going to have the same slope, up 2 over 1. If it has that same slope, there's no way it's ever going to get over here and touch this orange line, because I'm going up 2 over 1. I'm never going to like somehow veer off to the side and hit that line. So if two lines have the same slope, they will never touch each other. And let's see here how we can make this happen for ourselves. So let's say if I have y equals 2/3 x plus 1. Right, if I wanted to graph that, I'm going to go up to 1, put a dot, go up 2 over 3, up 2 over 3. I'm following the slope. Going backwards, you don't really need to. This is our original equation. Y equals 2/3 x plus 1. Okay, what if I want a line parallel? The symbol for parallel is 2 bars. So if I want a parallel equation, all I got to do is keep the slope the same and change the y-intercept. Let's do plus 4. Why not? So a parallel line here is going to start up at 4, and it's also going to go up 2 over 3. Right? A parallel line has exactly the same slope, right? It follows the same pattern. It's just starting from a different number. That went right through my equation. That's it. Parallel lines have the same slope as each other. They just have different y-intercepts. I mean, I can make a third parallel line. Oh, let's do green. And this time let's do like -6. So again, the slope is the same. The pattern is the same. I'm just starting at a different value. So here I start at -6, but I still go up 2 over 3, up 2 over 3, up 2 over 3. And this line will be parallel to the other two. It's never going to touch it because it has the same slope. There's no way this is ever going to go like up 5 and not go over some amount. That's it. Parallel lines will have the same slope as each other. Again, if you need more time, just pause it. But perpendicular. Perpendicular lines, these are a little bit different. Yeah, it's throwing so many errors. Perpendicular lines. These are two lines that cross each other. And the key part of perpendicular is when they cross, they make little 90 degrees. So perpendicular lines have 90-degree intersections. All right, the symbol for perpendicular, upside down tree, upside down T. All right. It's basically a perpendicular intersection. And if I look at this picture here, assume you have some line. You want a line going the exact opposite way. So again, this is going to have to do with slope. Perpendicular lines they can't have the same slope, because if it was the same slope, you'd get some other line that was going up with it. They go in exactly the opposite direction, right? So like this one here is positive, this one's negative. It's going opposite direction, and it's generally opposite everything. Perpendicular lines, they have opposite slopes. And there's a little bit more to it than this. Technically, it's an opposite reciprocal. Because it is completely opposite. It is opposite of everything. So like here, I have 2/3. Perpendicular function would be the exact opposite of 2/3. So it'd be negative. And then the opposite of up 2 and over 3 is 3 over 2. Down 3 over 2. Remember, slope is like directions. The opposite directions, you do exactly the opposite thing. If this was 5, perpendicular to 5, remember 5 is 5 over 1. The exact opposite of that is negative 1 over 5. So perpendicular, they have the opposite slopes, exactly the opposite. It's the opposite directions, and it's also the opposite sign. So what this looks like. So we're going to go back to our equation from the very beginning. Y equals 2/3 x plus 1. Yes, yes, yes. I'll graph that again. Start at 1. Let's use a different color. Start at 1. Go up 2 over 3. Now, to get a perpendicular function to this, I want exactly the opposite slope. So the opposite of 2/3 is 3/2. It was positive, so I'm going to make it negative. The y-intercept, make whatever you want. Let's do +2, why not? So for this one, if I start at 2, right, because that's the y-intercept, and then here it says -3/2. So for my y-intercept, I'm going to go down 3/2. Down 3/2. Right, I'm following this slope here, my perpendicular slope. Down 3/2. And what that does is this gives us the exact opposite direction line. And if we were to measure the angle between these two, this angle here would be perfect 90-degree angle. And that's it. Perpendicular lines have exactly the same slope. What I'm going to do now is go over one more of these just so you can see what it looks like, and then leave you to do the worksheet, which is basically you're given an equation, you find out a parallel and a perpendicular one. One did I not turn on? All right. Let's see what it looks like when you do something else. All right, so if I give you an equation, let's say y equals -2x plus 4. If I graph this first one, right, remember, start it here, the y-intercept, the slope is -2/1. So for my initial start point, I go down 2/1, down 2/1. You do it a bunch of times, down 2/1. Each time you do it, you draw a point. When you're done, draw a line through. There you go. I'm going to label this -2x plus 4. Okay, if I want a parallel line, let's do that in pink. No, let's do orange. So a parallel line, a parallel y would equal the same slope, just some other y-intercepts. Let's say 1. So again, this one, slope is still the same. It's -2/1. This time, though, I start at 1. I'm going to start at 1, and I'm going to follow the same slope, down 2/1, down 2/1, down 2/1. You see I get this line that is really close to it, but it's never going to touch it. And then if I want a perpendicular function, right, at a perpendicular to my original, all I got to do is I got to take my slope and do the exact opposite thing. So instead of going down 2 and over 1, I'm going to go up 1 and over 2. Right, but all this is this original fraction, the opposite reciprocal. If you take 2/1 and flip it upside down, you get 1/2, and I switch the sign from negative to positive. The y-intercept, again, just make it some number. Let's do -3. I'm going to start at -3. I'm going to go up 1/2, up 1/2, up 1/2. I'm going in the opposite direction. A perpendicular line is the exact opposite. And that's it. Look, I got my 2 original parallel lines, and then I have this one perpendicular. It's just perpendicular to both of those parallel lines. And that's it. That's parallel and perpendicular lines.